We have to get to a place where we think of every bit of information we have is really just a feature of the other information that we have. So the econometric inputs that go into an MMM model are usually going to be a handful, and there'll be a big argument about housing starts, consumer confidence, oil, right? You have to restrain the amount of that stuff that you put in there for a bunch of different reasons. And most people inherit the ones they're going to use anyway because they're the ones they've already used. The advantage today is you do not have to make those trade-offs. The unemployment rate for the quarter is a piece of aggregated information that might go into an MMM model once a quarter. But the unemployment rate at the time of the timestamp of the impression that you bought, that's just a feature of that impression. One of those features that be associated with it is just a discrete value from an aggregated MMM input. So at the time we bought this impression, this is what oil cost in that market, this is what consumer confidence was. You can start taking these aggregated inputs and disaggregate them and make them features of an impression, and then let the math tell you what the relationship is between them, instead of just starving the model of just the 2 or 3 inputs that you understand. Turning these big aggregate inputs into dynamic time-stamped features of an impression allows these algorithms to go in and find connections with stuff that you would never find. There would never be the granularity. And I mean, 300 is a constraint today. There's no reason why 10 years from now we couldn't be talking about 3,000, 30,000. That's what the math is great at, is don't force it to affirm your presuppositions. Let the math tell you what the pattern is and give it as much useful feature information for that purpose as possible. The future, you could not have done that historically. You were constrained and in ways that you currently aren't. The number of features you can bring in changes the game.